All right, well, I'm Greg Kazanza. I'm a program manager in Windows Server on the networking team in Windows Server. My primary area of focus is on software-defined networking and making sure that all of you can get the same kind of agility in your on-premises data centers that you've become accustomed to when you deploy into Microsoft Azure. When you deploy into Azure, you get to basically create everything that the network needs at the same time that you deploy your application. And so that makes it so you can really spin things up quickly. And a lot of you have become used to that. You come on premises, though, and, well, you don't have that same agility. You have to go and configure devices, hardware devices. You have to talk to a lot of different admins. So SDN gives you a lot of that same agility that Azure gives you. And of course, one of those key areas of agility is being able to secure your network. Because when you can create the network very quickly, you can very quickly create the necessary security policy that goes along with it, and very dynamically to really fit and be tailored to the application that you're deploying. So that's what we're here. We're here to talk about securing your networks with SDN. This is a 300-level session, so I will be showing PowerShell. All my examples will be with PowerShell. It's a great way to see really what the network controller can do. So just want to warn you about that. There are a lot of principles that I'll be talking about that even if you don't like PowerShell or kind of are afraid of it, you can still learn a lot by just listening to what I'm telling you and some of the best practices that I'm recommending. So that will hopefully help you out along the way. But if you don't like PowerShell, sorry in advance. All right. So why are we here then? If my clicker will work, which it did before we started. I have to use the mouse. Let's try one more time. There we go. All right, you may have seen this if you've gone to any of the other security sessions, right? Security costs a lot. You hear a lot about, identity theft or, different types of theft of critical resources from companies. And companies spend a lot of money on this. How many of you have actually contributed to this $3 trillion that have been spent? It's OK if you want to cover up your badge so nobody sees who you are. Any of you? Well, good. You're all here probably because you're aware of the hazards of malicious attacks against and cyber threats against your networks. I stole that slide from a dean who owns the assurance and secure VMs. So I made up a slide of my own that shows a little bit more about the rate at which these types of attacks are increasing. In the last 2 years, the number of hacking, skimming, phishing breaches that have taken place, not just attacks, but actual breaches, has doubled in the last 2 years. And if any of you are looking for a new line of work, well, information security analysts, it's growing faster than all other computer occupations out there. So it's really a huge area. I think you've figured it out by now. We've been putting a lot of effort into securing your virtualization environment, securing basically everything we can so that you don't become one of these victims. The reason why there are so many of these victims of these cyber attacks is that the traditional security boundaries that a lot of you have built up for years now generally don't work anymore, right? You build up a set of very large zones of security, right? You create a DMZ, you create a backend, you have a firewall that sits in between them. But those hackers out there, those black hats, are going to find a way in, right? They're going to do a phishing attack, get a set of credentials, and come in through one app. They'll take their time doing that first attack. They'll work their way in through the firewall to that app. But once they're into that DMZ, even if they can't get through directly, they'll start to attack the other apps in that same zone. They'll eventually get through to the next zone. They'll attack the apps there, and eventually getting to what is really, they consider the valuable assets, Active Directory, your file servers, basically pulling in things. And this part of the attack can basically go on for a really long time. Some of the analysis we've done shows that the initial attack takes only a couple days. But once they actually get in and get to that data, they can sit there for as much as half a year. I mean, a lot of you may actually have had your networks breached now for 6 months. You might not know it yet. So it's kind of scary stuff. I like to do a quick demo where I kind of show and give you an example, kind of a real example of how this stuff can happen. Switch over. Oh, I'm on number 6. I call this my black hat demo. I actually have a black hat so I can enter the world of the attacker. But before we do that, let's say we just finished deploying our application, right? We brought up a new application. In this case, it's Greg's networking blog. It's up and running. It's great. I'm very happy with that. So I go check some of my email. Oh, I didn't eat lunch yet. I got this email for free tacos, right? Now, most of you know this is a phishing attack, but people fall for these all the time. You get to a website that may look like, a legitimate website. This looks legitimate, right? You enter in your credentials. And with that, I'm perfectly happy. I think I've got tacos coming. But what I've really done is I've given my credentials away. Now, this is one way that hackers steal credentials and get in. How many of you saw USB sticks out on the show floor, right? Here's one. I assure you this Windows Server one does not have any malware on it. But it's another way that hackers get in and can get onto, potentially even a non-malicious user's laptop that they then plug into a corporate network. And now that laptop will have a bot on it that can go in and start attacking. So now let's enter the world of the hacker for a second. Nope, I've already logged myself in. Well, let me close and reopen this. Start from scratch. Put on my hat. So what I would have done as a hacker is I would have probed that service that I just deployed. I would have looked for open ports, right? Port 80 is open. In this case, I found that RDP port 3389 is also open. And so now I'm going to use those credentials that I actually went out and attacked the deployer of this application. I phished them to get that set of credentials. I'm going to enter those credentials in. So I'm going to hit that service and then log in. So this takes me into the web server, right? The web server, I can go in, I can deface the web server. That's kind of interesting. But what I really want is to get to those critical assets. And so from this one entry point, I go and I would most likely upload a script. Let me launch PowerShell to do that. I'll run as administrator, why not, since I'm in here. I can do that. I will go to where I uploaded the script. And the script will go out and start to look for things. It'll look for Active Directory. Active Directory is one of those assets that we like to pick on as being very vulnerable and needing a lot of protection because it essentially has the keys to the kingdom, as we like to say. And one of the other challenges with Active Directory is that, well, it has to have a lot of ports open, right? You need to have Kerberos, you need to have LDAP, you need to have DNS, you need to have SMB, right? All of these ports need to be open. So it's one of those things that hackers like to look for, right? Here I see that, well, I have a weak ACL and even the share for my C drive is open. If I have admin credentials, I can get to the ntds.dit file. I can then start my browser. I can just copy this through RDP just by doing copy-paste and get it to my local machine that way. Or I can even open up the browser, go to OneDrive using another set of stolen credentials, and upload it to offline, and now basically hack and do a brute force attack against that credential file, taking as much time as I want with that. So I mean, that's the risk we're all facing, right? And so that's why we're here today. All right, so let's go back. Slides. So this week we've been talking a lot about different ways to protect that. I mentioned that AD is we like to pick on that a lot, and we've been doing a lot to lock down AD. We have managed privilege identity, just-in-time administration, just enough admin. A lot of those things will protect Active Directory, through identity by making sure that, even if you are an admin, as an admin, you don't have the authorization to do anything against AD unless you're given it, even for a short period of time. We're doing a lot to secure the VMs to protect them against malicious admins that may want to go in and steal things from the VM while it's offline directly from the VHD. That's the kind of the middle orange area there. And then off on the right, we have down in the corner SDN with microsegmentation. SDN is all about taking your traditional firewall and a lot of your traditional networking protections and giving them the agility that you need to be able to make sure that these attackers, if they get into that first hop, they're going to have a really hard time even getting to that next hop and further in, so that hopefully you wouldn't even need to necessarily protect yourself with those other items. But you definitely should, because it's all about multiple layers. Security is not one-dimensional. So how can SDN help? Well, SDN, as I mentioned, it gives you Azure-like agility, right? You get the ability to create the network and all of the network services, whether it's load balancers, network security groups, as we'll talk about in a little bit. You get to create your address spaces, and you get to create everything that the application needs at the time you deploy the application. We call that agility. At the same time, this agility lets you create things really quickly, right? And so you have to make sure those things you create are secure. And so we have a lot of tools in SDN that I'll be talking about throughout this session that give you that security. And of course, SDN actually helps you lower costs, because no longer do you need very specialized hardware from third parties, you can take that third-party technology and bring it in as a virtual machine, right? All that third-party technology you love, you can still use it with SDN, but do it in a way that you can use VMs. And now your hardware and your infrastructure stays very consistent throughout your environment, scales really well, but it lets you use whatever technology you need in order to get the job done. So there's a lot of work that we did in Windows Server 2016 with SDN. A lot of it is centered around a new role that we have in 2016 Data Center. So everything that I talk about with SDN is available in 2016 Data Center. You don't have to buy anything beyond that. So the network controller is that central point where you issue your policy. It's the one place where you go to say you want to create a new network. You want to create a new subnet. You want to attach a VM to that network. You go to the network controller. The network controller then figures out which of the Hyper-V hosts have VMs that need to participate in that network or need to get these settings. And it goes out and it programs the virtual switch to go and do whatever's needed to make that command that you gave the network controller possible. You interface through the network controller through one of your existing management tools, either System Center VMM, PowerShell, eventually the Azure Stack. These are all built on top of the network controller and can go in and do a lot of what I'm talking about today. Now, when I say the network controller goes and programs the virtual switch, well, what I really mean is there's a component in the virtual switch that we call the virtual filtering platform. This is really that piece that gives us that Azure, why we say Azure inspired. Well, we did take some technology for the network controller itself from Azure. We built a lot of management interfaces on top of that so that it's usable by all of you. But we also took this component that runs in the virtual switch. It's called VFP, or Virtual Filtering Platform. We share this actual code of this component with Azure. We build independently, and then we ship this in Windows Server. And what this does is this basically consists of a set of flow tables that for every packet that goes through that virtual switch, that flow table looks up a rule. If that packet matches the rule, then it applies some action to it. And so we can do things like create virtual networks. We can do parts of load balancing. We can do security policy enforcement. We can even do routing with it. It's very, very powerful, and it's highly optimized. We take advantage of hardware offloads where possible, and we can get close to 40 gigabits per second. It's really architected to go beyond that even. Just real quick, if you've opened up the Hyper-V Manager and looked, you see it there. By default, it's unchecked. If you do check this just by chance, you'll probably get the most secure VMs possible, because they'll have no connectivity just by doing that. There's a fair amount of work you have to go through to get SDN up and running. Before we go to that, though, let's talk a little bit more about the flow tables. So the flow tables are made up of a set of rules, right? We have rules that are used to create a virtual network, right? If you match a machine that's on your virtual network, then it'll do the encapsulation into VXLAN in order to send the packet on the wire using a physical address space and then translate it back to the virtual address space of that virtual network. We have rules for doing NAT operations. So the load balancer, key part of load balancing is being able to do NAT, to translate from the virtual IP at the front end to the what we call the dynamic or data center IP on the back end, the DIP. And so we do a lot of that in the virtual switch as well. And then, of course, just doing allow and block rules, your basic access control lists. We have tables in VFP for doing that as well. And so basically, when we fill up these tables, or at least when the network controller fills up these tables, it fills it up with a set of rules to match. If you're going outbound from your blue VM on the right, you're going to 10.1.1/24, the packet will get matched and will allow it. But if you're going to 10.4.16 or /16, then it'll block that. And then there are a lot of optimizations that take place behind the scenes in order to make sure that after that first packet goes through and each one of these tables gets processed individually, we collapse it down into a hash table, so then further packets on that same flow just do a quick lookup and then apply all the rules at once. So it's highly optimized. Oh, yeah, here we go. The controller goes and does all that programming. All right, so let's talk a little bit. I mentioned that VFP, you don't just enable it. You need a network controller, of course, that can go out and program VFP for you, because there's a lot of computation, a lot of updating that needs to happen, especially if a VM moves from one Hyper-V host to another through live migration or a failover. The VFP component, that extension, needs to get programmed wherever it ends up. So you need to have your network controller deployed in a highly available manner. So for high availability, we want to have 3 network controllers so that if you lose one, you still have quorum with 2. You can deploy with one. You don't get any high availability, of course. You can actually deploy everything onto a single Hyper-V host for a lab or demo environment, but you don't get any high availability, so it's not really production ready. That'll give you basic virtual networking by deploying that controller. Virtual networking isn't too exciting by itself, though, because you can't get anywhere with virtual networking. You're completely isolated. So you need something that will give you access in and out of that virtual network. And so for that, we have in the box, again, in Windows Server 2016 Data Center, we include a software load balancer that gives you the ability to get in through a single load balanced VIP. It gives you outbound NAT access. So if you're on a private address space in your network, the load balancer gives you the ability to do NAT to get outside of the virtual network. We also include what we call multi-tenant gateways. These are just basic routing gateways. So you attach one of these to your, you deploy it as part of the infrastructure. Then when you configure your virtual network, you say, oh, I want to have a route onto a VLAN, and then the multi-tenant gateways will route onto the VLAN. So that's your other way of getting out of your network. And those multi-tenant gateways, they can do just routing onto a VLAN, onto across the site-to-site tunnel, across a GRE tunnel. So lots of ways to get out through the gateways. You have a number of ways you can actually deploy the controller. This session isn't really about deployment. We actually did one a couple days ago. We also have a lot of information on TechNet up top about deploying. Search for SDN in technet.microsoft.com or go to Bing. If you do Microsoft SDN, it'll take you right to our TechNet page. And it'll walk you through these different options for deployment, right? We have a tool called SDN Express. You just fill out one configuration file. It's a PowerShell DSC script that you run, and it'll go and it'll deploy network controllers, it'll deploy gateways, it'll deploy muxes all for you with one command. We have SCVMM service templates. Those are available on GitHub as well. These will let you deploy through System Center. If you are managing with System Center, then you need to deploy through System Center because System Center needs to go in and create a lot of objects that it's aware of in there. So if you're using System Center, then you'll go in through option B. We are in the process of publishing an SCVMM SDN Express version that uses VMM PowerShell. So if you're familiar with System Center, you know there's a lot of clicking you have to do. I used to be on the VMM team. I know that really well. We're publishing a script that will, like SDN Express, it's just one configuration file you fill out, and then you run it, and it'll go and it'll use the service templates, and it'll go and deploy the controller, add it to VMM, and get it all up and running. Finally, if you are using Azure Stack down the road, well, Azure Stack has a very high dependency on SDN. So as part of the Azure Stack deployment, it deploys network controllers, configures all the hosts to use it, and all the load balancer muxes and gateways. So these are your basic deployment options. That SCVMM SDN Express script will be available roughly middle of October, around the time you can actually go and buy Windows Server 2016. So. All right, so let's get into why we're here. All right, I'm going to cover 4 ways that SDN makes your app secure. And I'll go in. This is where I'll actually show you, how each of these areas makes your app secure, and then how you actually set it up using the network controller. So the first one, actually my slide already advanced for me, is virtual networking, right? I mentioned it already. You create a virtual network. That virtual network is a bubble of isolation, right? You can't get into that network. You can't get out of it, right? It's completely isolated by itself. The only way to get in is if you actually open something up that lets you in. One of the most common ways to do that is through the load balancer, right? You create a load balanced endpoint that represents the application that you're deploying into that virtual network. And now you only have that one entry point in. Let me just squip through some of this. The other thing you do with that virtual network, right? So you have the public VIP. That's your entry point in. The virtual network also lets you configure, as part with the software load balancer, outbound NAT. So you can now get from inside this virtual network, any machine that needs to get out can get out. You can configure that as well. So you have to actually enable that, though. It's not there unless you actually say, I want outbound NAT. The virtual network can also be made up of multiple subnets, right? This is where the idea of micro-segmentation comes up, because you're no longer having these large segments of DMZ backend corp anymore. You're now creating a segment per tier. And we'll get to why you do that in a little bit. But you have this ability with SDN to do that. And SDN, the network controller, and this virtual filtering platform extension will automatically configure the routing so that you can route between each of these subnets just by the fact that you've created it and told the controller about it and added it to the virtual network. The virtual router, the distributed router, is automatically configured and enabled. And then, of course, if you can do this for one app, you can do it for every single one of your apps. I'll talk a little bit about some of the guidance around this and why you want to do this in a little bit. But the whole idea is virtual network isolation. You can create that very dynamically with every application. You can give it its own virtual network. You can then have complete control over the security of that network. So I'm going to jump in, just show you a little bit about virtual network creation in my demo environment. Oops, 6. So I'll just show you what I did behind the scenes, to get this application up and running real quick. So here I have my PowerShell script. This can all be done through System Center VMM through the UI, well, at least the virtual network creation part of it. So what I did was here in the basic virtual network creation, I have this function that I called. I create some objects. And then basically, I define for each subnet that I want, I say new subnet. I give it a resource ID. I define what subnet I want to create. And then I define an access control list. I'll talk about these more in a minute. This goes into a helper function, new subnet, that just populates a subnet object with those properties, just a helper function to make it a little easier. Just this a little bit. And then I go to the network controller and say new network controller virtual network. That new network controller virtual network is a wrapper around the REST API of the network controller. If you are using System Center VMM, doing this through a VM network in VMM, then VMM is calling this function for you. And it's basically going and it creates in the network controller all of the metadata needed for this virtual network. I then go and apply it to my VMs as needed. This is a helper function I have called new IP configuration. And it basically says for each of my network interfaces, I'm going to attach it to a virtual network, the subnet within the virtual network, and I'm going to give it an IP address. And so right below that, I do attach VMs. I call this once for each of my VMs. So here I do it for my first web server, VM1. I call that new IP configuration. And then I also do a put for that with new network controller network interface. This goes and tells the controller, hey, this VM is allowed to be connected to this subnet in this virtual network. And I also tell it which IP address to use over on the right side. And so I repeat this, multiple times. I also have similar scripts that I use for doing the enabling NAT. So I do that through the load balancer. This is a little more complicated because I have to have a front-end IP that I use to NAT to. That's this right here. And I create a back-end pool, and I give it a few of the rules that I need to say what kind of NAT I want to do. In this case, I'm allowing TCP out. And just like I did before, I do new network controller load balancer, and that puts it in the controller. I do this also one more time for the VIP that I want for the entry point into my app. In this case, though, the VIP has a little bit more because I'm defining the inbound ports that I'm going to allow in. So here I'm expanding that. I have a separate VIP for that. This is my public VIP. See up at top, this public VIP. I have the virtual IP address, which I defined up above in a variable as well. There it is, my .6 address. This is the one I'm actually using a lot for referencing to connect to. I have my probe is commented out, but we do have health probes to keep the back end. If one of the instances goes down, we'll know not to load balance to it anymore. And here's where I basically define what gets to come in. I get to define, for TCP port 80, I'm going to load balance to whatever's in that pool that I've defined up above. Here I have RDP enabled as well, RDP 3389. I put that in the controller as well. Now I have to create a load balancer. If you actually look down below when I ran this, and I applied to each of the NICs, it took 12 seconds. I created a virtual network. I created 3 subnets. I attached 7, how many VMs? 5 VMs. Created a configured outbound NAT. I created an inbound load balancer IP, all in 12 seconds. So it's very, this is what we mean by agility. And you have full control over how you get in and out of the network. So some of the guidance around creating a virtual network, right? Now you have this great amount of power, this great agility. Well, you need some guidance to know how do you actually use it to make yourself secure, right? Well, first recommendation, create one network per application. Sure, you can create a virtual network, connect it to a forwarding gateway, and route in and out and deploy everything into that one virtual network. That's not microsegmentation, and that's not going to give you any more security than you have today. So create one network per application, just like you would do in Azure, right? When you deploy in Azure, you create one network for your application. It's on your own private address space. You can do the same thing with Windows Server now with SDN. Then, don't stop there. Create one subnet, especially if you're using private address spaces with NAT, which is the third piece of guidance. You can give it a private address space, and now you can have full control over how many subnets you create, and you give each tier of your application a different subnet. And this will be important when I get to ACLing. Only enable inbound on the ports that you need, because this, now that you have this wrapper around your network, you have full control over what needs to get in. And so you only need to enable those ports that your application needs, in case it's port 80, port 443, if it is a modern SSL-based application. Only enable that way in. Don't enable everything. And of course, the same goes for NAT. When you enable NAT, you don't just do it on the entire network, right? You're actually enabling it on each network interface individually. And then the controller will go and program the switch extension, those flow tables I showed you, to only enable NAT for the VMs that you gave NAT access to. So that's another way to protect with virtual networking. And then, of course, only enable your routed gateway if needed. Obviously, if you can do everything through NAT and you have full control over that, and then you have control over who goes out, you don't need to use a routed gateway. The other challenge with a routed gateway is that now your address space has to be able to route outside of the network. So that adds an extra layer of connectivity, because now you have to work with whatever network team it is at the other end of that gateway to make sure that your address space is allocated and available. Of course, if you are using a routed gateway, or actually any of these techniques above, that's when number 2 comes up. And I've mentioned these already a number of times. I've referred to them as ACLs, or access control lists, but I'm really talking about the SDN firewall. This is really will be able to restrict the bulk of your traffic in a really efficient way. Because it is enforced by the virtual switch and that VFP switch extension I talked about earlier. Because it's implemented in the switch, it automatically scales. As you add new hosts, you don't add new appliances to go along with it. The firewall just scales with it, because every time you add a new host, you get a new virtual switch, and that virtual switch controls the traffic for all the VMs on that host. The other thing about the SDN firewall is that it's also configured on the port of that VM. So the VM can't turn it off, because the VM guest doesn't know that it's virtualized to begin with. So the firewall is controlled by the host. It's configured on the port. And so that port can actually restrict all the traffic that goes in and out of it, right? You don't have to go up to a gateway to apply these firewall rules. You can restrict east-west within the same subnet. So if we look at this network that I created earlier, you can then apply an access control list, as we call it in our network controller, to each of the subnets individually. And now you can basically tailor, and this is why I say deploy a subnet per application tier, because now if you have all your web servers on the same subnet, you can apply an access control list to that entire subnet. Later on, you go to scale out your web server. Well, guess what? You're going to get that same set of firewall rules on that new web server without doing any of the configuration, extra configuration against that web server. You can define a different set of rules then for your file servers, which are on a different subnet. You apply the access control list to that subnet, and then, of course, for your Active Directory, you have a third set of rules you can apply there. And so you can keep repeating over and over again. You start to get the idea. This is really where the power of microsegmentation comes in, because you're creating very small segments around your application tiers. Now, these access control lists, they can be reused over and over again. You apply one here, your access control list 1 to your web tier. If you have a web tier in another virtual network, you can apply that same ACL to that same web tier there. And then anytime you change that ACL, it'll apply to everything. So let's say you start off with port 80 and 443 both open. You decide later on you only want to allow SSL. You don't need port 80 anymore. You just lock it off on the access control list, and everywhere that it's used, it'll automatically apply to those VMs that are used. So I mentioned access control lists. In Azure, they're referred to as network security groups. We often use that term interchangeably. So access control list, network security group are really the same thing. And what it translates to is it's a 5-tuple stateful firewall rule, or a set of 5-tuple stateful firewall rules. This means you can define the rule based on the source and destination port, source and destination address, protocol, and we don't include in the tuples, but also the direction. And then you get to decide, if you match one of those, then are you going to allow or block that traffic. You provision the rules through the network controller. That's your central place, or your management tool that's talking to the network controller. That's your central place to go, and then the controller will figure out where are the VMs, what's connected to the subnets that I need to go and actually apply it to. You also have the option of applying it directly to a network interface. You could actually do this even for VMs that are on VLANs that are in your cloud. You can apply access control lists to those as well. You don't get to do it, though, to the subnet if that VM is on a VLAN. You don't get to do the subnet because the controller doesn't have full visibility of the subnet for that VLAN, because the VLAN can extend outside the cloud, and we don't know it. So we don't have full control over it. So we don't allow you to put the ACL on the subnet in the case of a VLAN, but you can put on a network interface that's connected to a VLAN. So you can still use ACLs even if you're not using virtual networking. And of course, I mentioned before, it is enforced by the virtual switch. I'm actually going to jump over and ACL properties. Well, we've got quite a few of them. I talked a lot about these. You have the type inbound, outbound. If you're using a source address, destination address, you can do an exact address. You can do a subnet to match. You can do 000 if you want to match everything. This is what you use for your default rules. You can also use an asterisk. That also is a wildcard for all addresses. We also have this notion of a tag, and I'll get to those on the next slide. You might get to match ports. You can do specific ports. So if you want port 80, you define the rule against port 80 to allow or block. You can do a range of ports. The range is very useful if you want to, for example, allow outbound over the dynamic range of ports for RPC, for example. Then you use the port range. You get that. Protocol, TCP, UDP, or star are the basic protocols we support. Star means any protocol. And then for each of these, if you do get a match, then you define allow or deny. These are very straightforward if you're familiar with firewall rules and any other appliance out there. The final thing is the priority. This is the order that the rules are processed. The first rule that matches is the one that gets applied, and then all processing stops after that. So you get a priority from 101 up to 65,000. And so the lowest numbers have the highest priority. We reserve the lowest 100 and the highest 65,000 for internal use. And that's because we actually do put a set of default rules in place. We'll talk about those in a minute. The tags, so as I mentioned in the source and destination address, you can put tags in. There are 3 that we allow. If you're familiar with Azure Network Security Groups, these might look very familiar. We actually modeled it exactly after there for the Azure consistency that we need in Azure Stack. Your first tag is virtual network. This basically says this rule will match against any packet that is either a source or destination within your virtual network. So this is all your virtual subnets, plus anything that is reachable across a routed gateway. If you add a virtual subnet, the network controller will do all the calculations needed to basically apply that new subnet to the VMs that are connected to where this virtual network rule is applied. The internet is kind of the opposite of virtual network then. The internet is basically anything that doesn't match the virtual network. Applies there. And then the last one is the Azure Load Balancer. Again, we copied these from Azure, as you can see. This is the Software Load Balancer Health Probe. You don't know how many times I've tried to set up SLB with health probes and forgotten to enable access here. If you don't enable allow from the health probe, that'll be blocked too. And so it's very important that you keep that in mind. So the default rules, and the reason why you have to enable that health probe is because our default is to deny all inbound. So we have a rule 65500. It's always there. It's the highest priority we have, which means it's the last processed. And we deny inbound by default. So if you create a VM connected to a virtual network, create a second VM connected to a virtual network, turn off the Windows firewall in these VMs and try to ping each other, they won't ping. Well, it's because we block inbound by default, part of our secure by default philosophy. We do allow outbound, though. All outbound is allowed to go out. And as I mentioned, the health probe for the load balancer and all inbound bounce traffic is blocked by default, including that. So that then leads me to probably one of the first rules that you're going to define, which is the allow all ACL. Now, this is not generally the best rule to keep in production, but it is necessary for doing your initial deployment and testing and configuration. And basically what you do is you give a rule that basically matches everything, with the access to say allow, priority that's any priority really for the most part because it's always below the 65,000 range, which is where we put that default one. The outbound really can define allow all outbound too, but it's not really necessary anymore. And when you actually put that on the virtual network, what you end up with is both of those rules together, right? You get your inbound 101 to allow. You still have the deny all inbound below it with a higher priority, but that one will never get hit because it'll match the one above. And so that will allow all in, and it'll allow all out. This is what the PowerShell looks like with the network controller. If we do want to do this, a couple things of interest. Point at it with this. See here, can I touch? No, it's not touchscreen, darn. OK, right, so these all pretty much match the laser pointer. Oh, there we go. These all match the those properties I talked about before. You have your protocol, source port range, destination port range, action, address prefix, priority, type. We do have a logging property. You may see it if you look in there. It doesn't actually do anything today, so we don't have logging on our on the ACLs in the vSwitch today. So you can set it to enabled or disabled, same effect. You then put that into an ACL rule. These are right now these when you do new object, it just creates an in-memory object that you set these properties on. You give it a name, in this case allow all outbound. You assign it to an array. This is now becoming your access control list. This rule becomes a list. We go on to the next slide. You then take that list, put it in a set of ACL properties, or create a set of ACL properties, apply those rules to the properties, and then you do a new network controller access control list to apply it to the controller. And that's basically how you do your most basic access control list. Now, just creating the access control list doesn't do anything because you haven't applied it to anything yet. Next step is creating a virtual subnet and putting it on that ACL in the subnet. So this ACL, if you don't already have it in a variable, you can get it again from the controller. And then you can assign it to the access control list that way. So in this case, I'm creating a virtual subnet from scratch. This is actually very similar to what I just showed you. I'm creating it with the 192.168.0.0 subnet. If you want to create it, or if you want to turn off this ACL, then you just set this access control list back to null and re-put the virtual network object. Now, even if you do turn off the ACLs, you still get that default rule. So you are still using ACLs whether you like it or not. So if you want to have your traffic unrestricted completely, then you have to do the allow all and put the allow all here. Then finally, after you've created the subnet, then you just create the virtual network. Again, new network controller virtual network, and that creates it. You can do the same thing once you've created that allow all ACL to a network interface. In this case, I'm creating an ACL. I named it something different called SMB only. And I'm applying it to the IP configuration on that network interface, IP configuration properties, access control list. And then I put that network controller network interface, and that now applies it to that interface. Now it's a unique one-off application of that NIC. Since you can apply to two different places, it's possible now to get a tie, right? Normally, rules are processed based on priority. But if you can have two different set lists with equal priorities, then you can end up with a tie. And so if you do end up in that tie condition, then for incoming traffic, apply the subnet one first. That one will take precedence over the network interface. And for outbound, then we do the network interface first, and then the subnet after that if it doesn't match. That's what we do for default priorities. A few more examples. This is an example. How many of you know what a PVLAN is? A few of you. PVLAN is basically a way to use VLANs to get isolation without creating a VLAN per host on that VLAN. It basically says you have a primary VLAN and a secondary VLAN. Anybody that's on the secondary VLAN can't see each other, but they can talk to whoever's on the primary VLAN. In this case, we can simulate that same behavior in a virtual network on a virtual subnet by applying the appropriate rules. So first, I defined a rule here for inbound that allows traffic to the Azure Load Balancer or from the Azure Load Balancer into the network. So this enables the software load balancer if you need it. We then say any traffic going to the 192.168.0.0 subnet, which is what I will be applying this ACL to, we're going to deny that traffic. So we're going to block that traffic. But then we're going to have a rule after that that is basically the default that says allow everything else. So basically it says if you're on this 192.168 subnet, we're going to block you coming in, and we're going to allow anybody else. And then down below for outbound, I basically do the exact opposite. I say if my destination is 192.168.0.0, I'm going to deny that outbound too. So I'm actually blocking it both ways. I'm blocking it both from the source and from the destination. If I go and then apply this to my virtual subnets 192.168.0.0, I've now made sure that any VM on there will not be able to talk to any other VM on that same subnet, but it will be able to talk to and from anybody that's outside that subnet. Here's another example. One of the best ways to secure your subnets is to do a block by default, and then you basically whitelist those applications and ports that need to get outbound and inbound for the most part. And so in this example here, this just shows you port 1433 TCP coming into my .1 subnet. I'm going to allow that. That is the default SQL port. I'm going to allow a few other things. The .1 here in this case is the Azure Load Balancer. I didn't use the tag in this example. Port 53, TCP and UDP are DNS, so I'm going to allow those outbound. And then I'm going to deny everything else outbound. This is probably one of the strongest ways you can protect your workload, keep from getting out once you've been compromised. And then inbound, you'll want to do something very similar. In this case, I'm enabling 3389 inbound to allow RDP in, and I'm allowing the load balancer in so I can load balance into this application. So this would be typical of something that needs to be load balanced. Let me jump into my demo environment again for a minute. Let me actually show you some of this actually in action. So I've created this virtual network already, right? There are no rules on it. The only protection you have is from the NAT operations that, in a way provide limited access to the network. So I have a second script here that I'm going to run that's called secure network. And what this is going to do is I'm only going to apply this to the one subnet that's my web server tier. So this is my 192.168.1 subnet. And I'm going to apply this access control list. And so what I'm going to do is expand it to find the right one. Here called network security group. I'm basically defining a set of inbound rules. Here I'm defining port priority 110, inbound allow from the internet to port 80. I then have my inbound default, which is to deny inbound. Everything else will deny. This all goes up to a helper function that then sets wildcards for everything else. If I go up to a helper, it's right up here. Here's my new rule helper. So my defaults are wildcards if I don't pass in the parameter. And that just sets it then on the object. I then have my outbound rules defined, which are also, which I have set. If I go down to my very last one here, let me scroll to the end. I have my outbound deny, which is my deny by default. And then up above, I have all my other rules. I have quite a few here, because this one I'm going to allow a number of different ports to my DNS server. In this case, here I'm allowing port 53 UDP TCP to DNS. Here I'm allowing Kerberos. Here I'm allowing LDAP, SSL for LDAP. And I think I also have, SMB. So this basically says that my web servers can get to AD. And then I'm going to go and then I apply that to the network controller. And when I get a little further down, I then apply that security group to my subnet number 1 right here. So here I apply it to the subnet, which is on the virtual network, and then I put that back into the virtual network. There's a little more that this script will do, but we'll talk about that in a minute. But let me run it first, and let's see what happens. So running the secure network, I just have some output here that shows me what it's doing. This will run for a few seconds. And it can take up to, I've seen it take 45 seconds at times, depending on what's cached in the network controller at the time. The network controller is deployed as 3 instances in this environment, and it's doing synchronous replication between each of those instances of the network controller. So when I do put the put into one, it then copies that put to all 3 of the network controllers, so that if my primary one goes down, then the secondaries will take over and automatically have all the right settings that are up to date. All right, so we've actually applied the ACL. We're going and doing a little bit additional configuration that I'll talk about in a minute. But let's go and see if this actually worked. So before, when I had my hacker hat on, and my hacker wallpaper, I was able to RDP in. So let's close, and let's see if we can RDP back in now. RDP. Well, it doesn't let us in, because I did not, and if you saw that list, it enabled a lot of things, port 80. It enabled a lot of AD stuff, but it did not enable RDP. So from the outside, I'm blocked. I can actually go back to within the virtual network. Let's go to one of the VMs that's inside the virtual network. Here I'm going to go to my domain controller, which is on the virtual network. This right here says web1.contoso.local. So I'm connecting from my domain controller to my web server. I can't even get from my domain controller to my web server. So I've really locked down traffic going around inside this network. Now, that's great being able to apply these firewall rules, but you also need them to be very dynamic, right? I mentioned earlier that once you've applied it to the subnet, anything that you put in that subnet gets the same rules applied. So I'm going to run one more script here, and this is going to add another web server to that network. So if you look here, if you scroll through here and look at what this script does, you can see we're getting the load balancer configuration, network interface, we create some objects, and we set some properties. If you look at the properties, it's just the IP address, which network we're connecting to, and then which load balancer pools we want to add it to. There's no security policy in here, right? I'm connecting it to the network, but I'm not defining any security policy. So I'm going to run this. That only took 1.8 seconds. And I've added the VM. The VM I already had created. I simply attached that VM to the network. And now, if I go to my load balancer, not that one, I've put on my web servers a unique page so that each page comes up with a unique URL. Here's web server VM1, VM2, and the third one I just added is VM3. So I did indeed add it. But now if we actually go to my domain controller and try to connect to it through RDP, everything went according to plan, that's blocked. So I got the same security rule. I can't get into it from RDP even though it's on the same virtual network. And I did that because I applied those security rules to the virtual network. All right, now let's say we actually do want to allow RDP in, because we need to go in and do some maintenance on this VM every now and then. We want to allow in port 3389, but we don't want to allow it in from the internet, right? We want to block from the internet, but allow in from within the network. These rules are very dynamic. You don't want them to be rigid and not be able to change. So I'm going to run another script. This one is the revised security script. And what I'm going to do is I'm going to get that control list that I applied. And I'm going to say, with priority 114, I'm going to deny the same subnet. So my web servers won't be able to RDP to each other. So this .1/20, or this .1.0/24 is the subnet that my web servers are on. I'm going to deny access inbound from that subnet. So this is basically things can't RDP to each other. So if one of them gets taken over, we won't be able to RDP to each other. And we are going to allow, though, from the virtual network. So anything else on the virtual network that doesn't match that, we are going to allow in. So this will basically say that, I'll kick off the running of it. That actually took less than a second to apply. Basically says we can get in from the virtual network, but not from the outside. So let's switch over. Let's see now. Back to here. This one timed out. Whoops. Let's go to local. This is from the outside now. Oh, whoops. I do want the 192.168. 10.127.132.6. So doing the RDP from the outside, still blocked. So that's good. Let's go back to our domain controller, which is inside the virtual network. Connect. And see, this let us through now. So just like that, we give ourselves RDP access, and this will log in. Now, I also, if I try to connect to Web 2 and Web 1, it would also let me through, because that same security group automatically got applied to all of the web servers. All right. So those are the access control lists. This is kind of your quick and dirty way of locking down your network. But there's more, right? A lot of you have third-party technology that you love, that you invested in that you need to use from a management perspective because they have all of your corporate rules defined already. A lot of you have appliances that you have to use. You have them as physical appliances. But you want to be able to now bring them into the virtual network. And so number 3 is the third way that you'll make your app secure, and that is virtual appliances with user-defined routing. If you've used user-defined routing or UDR in Azure, it's the exact same thing, but for your on-premises virtual networks and data centers. And the whole idea there is that you can bring in a VM that has some appliance, typically Linux or BSD, and you can basically define the routing table. I mentioned earlier that when you create these subnets, we'll create the routes to go between them. Well, you can override those system routes with your own user-defined route table and say that any traffic that is coming from subnet 1 or subnet 2 that goes to subnet 3, you want to route it through this virtual appliance. We'll jump in and we'll show you that real quick. And so actually, that was already part of the script that I ran a few minutes ago. If we actually go back, we'll scroll up a little bit. You can see here, after I apply the network security group, I create a route table for my .3 subnet, which is where my Active Directory is. Go back to my secure network panel. You can see here, I add the virtual appliance, update routing table. Simply a matter of, let's see here. Well, first you have to actually attach the virtual appliance to your network. So here I attach it to the .3.254 address. So here it is over here, where I attach it. And then I define the routing table, which is the next function that simply says, if your address matches the .3.0/24, then send the traffic to the .3.254 as the next hop for the routing. And then we apply that to each of the subnets. In this case, we're doing the subnet 1, subnet 2, and even subnet 3. So subnet 3, which is my .3, I'm applying this routing rule to it. One thing that's different about the way we can do this with SDN, because we're applying these rules on the port of the VM, we can even match that route for traffic that's being sent within the same subnet. So anything that's destined for a .3 subnet, even if its source is on the .3 subnet, where normally it would go directly across the L2 from one VM to another, it will get sent to the router. And so you actually can force all traffic to go through your virtual appliance that way. So something that's a lot more difficult with a physical appliance to do that is actually set up as a traditional firewall. And so I have, when I've applied that, I actually have my Linux VM here. You can see here that this is a tool called iftop. It basically lists all of the traffic flows that are coming in and out of an interface in Linux. You can see here that basically we're matching anything that is going to, in this case, from the .1.12. This is actually my 3389. This is my RDP port. This is the one port that I opened up. You can see right up here on top, which is most of my traffic. And it's going to the .3. Actually, let's pause that so it stops moving on me. It's going to the .3.10, which is the domain controller, which is where I initiated from. So you can see here, we're actually sending that RDP traffic through this Linux appliance. This Linux appliance can now do whatever deep packet inspection it needs to do. You can invest in whatever technology you want from whatever third party you want. And as long as it runs as a virtual appliance on Hyper-V, you can bring it into your virtual network, and you can use it as the router, as the firewall, as whatever you want it to do. A little bit more about that. I mentioned some of the things you can do: firewall, IDS, intrusion detection. It's not just security, though, right? You can use these appliances for other things. WAN optimization, load balancers. There are a lot of great load balancers out there that do things that are highly optimized for certain applications, doing SSL offload. Load balancers are also great security appliances these days. So you can bring those appliances from whatever vendor you want, whatever vendor you've invested in and trust. You can bring that into your virtual network. You can use their same management tools that they have for their appliance in your virtual network. We do a lot of work to make sure that Linux and BSD-based appliances perform really well in Hyper-V. We have the saying within Microsoft that says we want a appliance to perform as well in Hyper-V as a Windows appliance or as a Windows VM. And we also want Linux to perform as well in Hyper-V as it does on our competitor platforms as well. So we do a lot of investment directly into the Linux kernel for that. And as I mentioned, these appliances don't need any integration with well, really anything other than making sure they run on Hyper-V as a VM. They don't need to be integrated with our SDN controller. They don't need to be integrated with System Center VMM or have any plugins of that sort. You just put them in the virtual network, attach them, and they'll start getting packets just as they would if they were on a VLAN. So that's great. And as I mentioned again, I said it once already, I'll say it again, these are just for security. You can use a variety of these appliances. A little bit more about, I think I covered a lot of this already. UDR, you can override the system routes because the system does set up routing by default. We did make it to be consistent with Azure, and I mentioned same subnet, so I already did that. I showed you the routing table live in my demo environment. You first connect the appliance, set up your route table, and then you configure within the appliance what you actually want it to do with those packets. In my case, I just configured this Linux VM to just do basic forwarding, so I could see the packets but not actually do anything to it. And then you apply it to your subnet. High availability. You have now, since these appliances are now in the data path, availability becomes, important, because if this appliance goes down, now all of a sudden you have no way to get from subnet 1 to subnet 3. And so availability is important. You have a few options. Now, you can't just use necessarily the clustering technology that the appliance has, because a lot of them do have clustering technologies, but that relies on the ability for an IP to move from one appliance to another, or maybe doing some trickery with the MAC addresses so the MAC addresses get moved around. With SDN, those technologies don't work in the same way that they would on a VLAN. So you have to take some different approaches. And if you've used user-defined routing in Azure, you've run into the same thing. On premises, though, you have one tool that you don't in Azure, and that's high availability of the VM. I call this the cheap and cheerful method of high availability, because you'll need one license of your virtual appliance to start, and it's very easy to configure. You simply make the VM a highly available VM. If your host goes down, or if you need to do maintenance on the host, you can just live migrate it to another host, or the cluster will fail it over to another host. You'll be down as long as it takes that VM. Well, if it's a failover, you'll be down as long as it takes that VM to reboot, which in my case, it's about 30 seconds. But it's very easy and very quick to do. If it's a case of live migration, then it's not actually down at all. Your option B, and this is something that's highly documented for a lot of these appliances in Azure. The same principle works here. Use SLB. Put it in front of the virtual appliance. This is key if that appliance is on the edge of the virtual network. In fact, you want all traffic that comes through SLB to go through the appliance. Well, then you tell our load balancer to send the traffic to the appliance instead of directly to the application instance. We can use the health probe to determine which of the appliances is the healthy one. And then the load balancer will automatically send the traffic to that appliance. The appliance then will forward using UDR to the application instance as appropriate. So that's your next option for high availability. And again, Azure documents a lot. Your third option is simply take the appliance out of the data path. Now, this only works for certain types of purposes, and brings me to my fourth way SDN makes your apps more secure. Virtual appliances with port mirroring. If you don't have to send the packet through the appliance, then you make a copy of it and send a copy instead. Now the appliance can take its time with that packet. It can do deep inspection if it wants. It can drop the packet. It can get behind. It can even reboot. Your VMs will still talk to each other, but that appliance will not impact that traffic at all, because we've made a copy of it and sent it to the appliance. Here's my little diagram. Whoop. I've got a demo here coming up in a second. Go back one more. Click one too many times. Yeah, basically what you do is you create an appliance. You apply a rule to the appliance saying, I want this appliance to be a mirrored appliance. And then you set whatever VM you want to get mirrored from. All the traffic that goes in and out of that VM will get sent to the appliance instead. One of the great uses of this is a product we have at Microsoft called Advanced Threat Analytics. Some of you may have seen it in other sessions or other demos. And what it does is it basically analyzes the Active Directory traffic. And so here I have an example that I've recorded of how to set up ATA. I'm using a very similar script. First thing it does is it attaches the Advanced Threat Analytics VM to the virtual network. In this case, it's the Advanced Threat Analytics gateway. That gateway is what needs to get a copy of every packet that's going to AD in order for it to process and determine if there are any attacks coming against AD. We define a set of rules for what packets we want to match. In this case, we're going to match all packets that are going in and out of that Active Directory server. We're going to send them to the Advanced Threat Analytics Gateway to be processed. And then finally, we're going to tell here the element is the ATA VM. And so as soon as we run this, we connect the ATA VM to the network. You can see ATA has picked up here, says there are no health alerts, because now it's gotten connectivity to the domain controller. And then the next thing the script's going to do is it's going to basically mirror from the Contoso domain controller everything to the Advanced Threat Analytics Gateway. Now, in Advanced Threat Analytics itself, we've already done the configuration to basically say that we wanted to look at the contoso.local traffic. Here we're still showing you the mirror setting to say that we're mirroring from AD to the ATA VM. I'm going to go over to the ATA VM in a second. Show you that configuration real quick. OK, no suspicious activities currently. We haven't actually done anything suspicious yet. We're going into the configuration now, showing you that we are configured for the contoso.local VM. So scroll down. There's contoso.local, or the contoso.local domain. And then the other thing we've done is we've set up what's called a honey token. This is basically a user account. In this case, it's the user account SID that says if anybody logs into this account, then flag it in ATA as a suspicious activity. So we've set up the guest account in this case to get flagged. And so what we're going to do now is go to one of our web servers. We're going to just log into that web server as guest. And if everything goes according to plan, it'll show up on the right side. Here we go, guest. Logging in with the password, which we've stolen somehow, or brute forced. We've logged in. And now because all of that traffic, that Kerberos login traffic that's going from the web server to the Active Directory VM is getting mirrored to the ATA gateway, the ATA gateway is able to detect, OK, somebody's logged into this guest account that matches my honey token SID, and now I'm going to flag it as being potentially malicious. And so now you could actually even go to the next step to automate, oh, this is actually in the same cloud. I can go and even block this, web server VM from getting anywhere using now my firewall ACLs. And so this is a great way to show that you can do mirroring and do all sorts of interesting things outside of the data path, in this case with Advanced Threat Analytics. The nice things about it are that you don't need to set up anything in AD itself. So if you didn't have this capability, you'd have to put in what they call a lightweight filter that would copy everything from within the AD VM itself to ATA. Of course, if AD gets compromised, it could turn off that filter. This is enforced by the virtual switch, so it can't get turned off by the domain controller itself. When we do the mirroring, we don't modify the packets in any way. We actually encapsulate the packet with VXLAN, the exact copy, and forward it to the appliance, as is, including the MAC addresses. And so when it gets to that appliance, you have an exact replica of the packet that was both going in and out of that machine you're mirroring from. Because we're using SDN and doing that VXLAN encapsulation now as we do the copy from the source to the destination, these don't need to live on the same host anymore. If you're familiar with mirroring in 2012 R2, all right, we got a fan of that. You had to have them on the same virtual switch. You could also only do one, right? You can only mirror from one source to one destination. Now you can mirror from many to a single appliance. And they can migrate anywhere they want independently within this cloud. That's one of the great things. Appliances out of the data path. You also have the ability to do rule matching. As I showed you briefly in that video, you can actually reduce the amount of traffic. If you only want to do a deep inspection of certain traffic, your port 25 mail traffic, SMTP, well, you can tell it to only send that traffic to the mirrors. That allows the appliance to now spend less time filtering out things that it doesn't want to look at. So there are a lot of things you can do with SDN-based mirroring that you can't do with traditional things. And just like with user-defined routing, the appliance does not need to be aware that it's part of an SDN network. It doesn't need to be integrated with SDN. It doesn't need to have anything like ER-span enabled. It will just get the packets as they were sent to and from that VM you're mirroring from. So again, a wealth of appliances. If they can do something like this, they can consume packets in this way, then it's a great way to bring it in there. Another way this can be very useful is if you do want to do something just monitoring of your network with like SFlow, NetFlow, you have that in a VM. You can then do the mirroring and use SFlow, NetFlow now to do some reporting that way as well. Just a little more detailed example of how we created the rule. We did the pattern matching the same way with the source, port, range, start and end, source and destination. You can match against subnets where you're going to and from. And then you apply that to you add an element, which is what you're mirroring to. In this case, that destination NIC is your destination right here. We got that earlier. And then we apply it to a new network controller. We use the service insertion command, because we call this service insertion, to do that mirroring. That's where we actually do it. All right, that is port mirroring. Shifting gears for a second, right? I did all of this through PowerShell. Well, everything that you saw can be used with SCVMM. You just have to be aware of how you can use it, because VMM only has certain things available through their UI and through PowerShell. And so I put this table together that shows you some of this. Virtual networks, VM creation, attach is fully available through the VMM UI and through VMM PowerShell. So you can click away and create your VMs and your virtual networks, your virtual subnets. The one thing is, if VMM has support for something, you have to do it through VMM if you're using VMM for management. So even though you could do it through the network controller PowerShell directly, if you do it through network controller, then VMM will have no visibility of it. So if you're using VMM, then use VMM for those things. VMM now has support for ACLs through VMM PowerShell. So if you want to set ACLs, you can set on the network interface, the subnet. They will translate those into the same concepts within the controller. Load balancer you can configure through SCVMM with VMM PowerShell as well. However, things like UDR and port mirroring, you have to do that through the network controller PowerShell. And you apply it to either the virtual subnets that were created by VMM or to the network interface in case of port mirroring, those network interfaces that were created by VMM. The VMM team did do validation to ensure that they would not override these settings because these are settings that they don't have any awareness of. They wanted to make sure that they would not get overridden if you did go and set them up. Now, I showed you PowerShell here. We'll get directly against the network controller, but we have a hands-on lab with SCVMM integrated with the network controller. You still have a day left of TechEd. You can actually go and check that out in the hands-on lab environment over there in between A and B halls. Definitely check it out. You can create virtual networks, create VMs. You set ACLs. I'm not sure what else you do. Possibly create a load balancer. Oh, one other thing about VMM. VMM applies a default ACL in addition to the one that is applied by the network controller. They reserve an extra set of priorities. At the very high end, I believe they set roughly 64900 to 65,000. So they set the very high end, roughly 100, at the high end of the range that is allowed by the controller. And they basically set that allow all for you on the inbound path. So that basically gives you the same functionality you're used to with VMM, whether you're going to a virtual network or not. They'll allow all in and out. But you can't override it. You can apply your own ACL to say, I don't want to allow all. You can do, set it to 64,000, put your own block all by default, and get block all by default. So with that, I've covered 4 ways. Now, everything that I showed you against the controller, virtual network, SDN firewall, virtual appliance, the user-defined routing, and SDN port mirroring is in Windows Server 2016 Data Center. You don't need to buy anything extra. Advanced Threat Analytics is a separate product. Your virtual appliances, of course, you have to go to the appliance vendors to buy those. But you can bring them in and use them. These are the sessions we had on SDN at Ignite. The first 2 have already happened. I hear this Thursday one about microsegmentation is great, so I encourage you to, you're all here. And we have one more tomorrow for those of you that are staying till getting every last minute out of Ignite. We have one about performance monitoring and diagnostics. We'll also have a little bit on time sync, work we've been doing to make time sync work really well with networking. We have that tomorrow as your last session you can close out Ignite with. And then, of course, don't forget about the hands-on lab. There's still time to do that. So with that, I want to thank all of you for staying here for your last session of the day, at least I think it is. And hope you had a good Ignite. And if you have any questions, I think I have 1 minute, and I'm not sure if there's anything left in the room after this. So thank you. Yes, question right in the middle. Yes, so we do only have round robin within there. You can set how many tuples are used for the hashing for that. You can basically say you want to have 2, 3, or 5 tuples, I believe. I believe we use 5 by default, in which case it'll be very random. If you set it to 2, then it'll be roughly source persistence. The only challenge there, because we still do a hash, if the number of dips changes, then that hash gets recalculated for everything. So if you have one of your dips goes down, all of your other healthy dips are going to get their sessions recalculated and reshuffled around. So that'll then have to reestablish sessions after that. If you're used to the load balancer in Azure, it's the exact same behavior. We actually inherited this setting from Azure. Yes?
All the scripting you showed here, how much of that is reusable for Azure?
The concepts are the same. Syntax. This is REST API against our network controller. Azure has its own API through the Azure Resource Manager. The properties are very similar, but they are not 100% the same. Things like port mirroring are not available in Azure. They don't have port mirroring that I know of, but user-defined routing, ACLing, virtual networking, of course, is all available in Azure. It's just slightly different. But we took a lot of this technology from Azure, made the REST interface tailored towards management of a Windows Server environment, and exposed it up. So you'll see almost everything will be the same, but it's not 100% the same. If you do want that 100% consistency, then Azure Stack is for you, because Azure Stack brings the network resource provider, which has that 100% consistent interface. At least I think it's 100% consistent with Azure proper service. So you do get that consistency back and forth. That's Azure Stack, though. Yeah, I know. You have to wait. You get consistent functionality today, just not consistent API going as a controller.
Okay, so there's still a good reason to use Windows Server SDN instead of like NSXT when running with that.
There's always a good reason to use Windows Server SDN for those, but yes. Yes. Yes, absolutely. Another question.
Have you paired the ACL capabilities with just-in-time or just-enough administration?
So the question is, how do you compare ACLs to just-in-time administration and just-enough admin? Those are identity-based and based protection. So basically, you've already allowed network access to the machine that you're logging in from. And these basically say that, OK, now that you've logged in, what can you do? And so just-enough admin says, OK, if you're a DNS admin, you can log in, but you can only do DNS commands. Just-in-time admin says, OK, you are a valid user, but you're not an admin unless I've given you a block of time in which you can be an admin. And so these are things you have to already have network access to the machine to use just-enough admin and just-in-time admin.
Well, my thought is that so from a privileged workstation, from your hardened workstation, before you hit that workstation, you're requesting this access. During this time, I need to hit this resource from this resource. I need this level of permission to do these actions. And you pair all of those in your PAM, and you go to that workstation, and it then provides that access through the ACL. It gives you access to the system, and then you can have the permission to do what you need to do.
Yeah, that would be a great next step, to tie the controller in to that. We don't have that yet. They're both very new components in Windows Server, and we just haven't gotten that level of integration together yet. So, but that is a great idea. Thanks. Question here. We do all of our policy distribution from the controller to the Hyper-V host using OVSDB in a unicast method. So we don't do any learning automatically of addresses between the hosts. It's all policy that comes from the controller. So no multicast is required. Of course, that also means that if you do have devices that do that kind of learning, they won't integrate until we actually have support for them from our controller. It's something, though, that we've embraced these technologies so that we can go in that direction. These standard protocols like OVSDB and VXLAN. We just don't have it yet with this initial release. Another question? Yeah, we do not have that level of logging today. So it's something we know is the next step we need to do. We just don't have it yet. Where would you like it to go? Let me ask you that. Since we don't have it today, this is actually a good time for me to ask you, where would you like it to go? SCOM? Event log, would that be a starting point? you could pull from there? No? Okay. Syslog. Splunk, okay. Okay. Thanks. Other questions?
Over here.
Oh, over there. Thanks. Sorry. I saw the crowd over here. I forgot there's another mic over here.
All right. So hey, Greg. So good to see UDR made it to systems. I mean, this 2016. For HA, you showed that UDR can send to software load balancer. So this is all ports protocols.
So sorry, Lee, it was a question about.
UDR can sort of for HA of let's say NVA like a firewall. You said you can send it to the software load balancer.
Yeah, so there is a challenge there because we don't have ECMP, the outbound path. You are right. So the load balancer comes into the virtual appliance,
Okay.
and then the appliance can forward it, but the outbound path, you're right, will not go through the appliance because the
Unless we do source
there's-
NAT or something in there.
yeah. So you can only you can only send it to the appliance on the inbound, but not outbound unless you have another.
No, not. But you mean return path of traffic will come back, right? Return traffic for inbound.
Return traffic
So if you've got
will
something that came in, the return traffic will come back.
go in. Oh, it will come in because it knows where it came from. So when it goes back out, it'll go back to where it came from.
Plain outbound new. Okay.
Yep.
Okay,
Yep.
but there's no port or protocol restrictions like the Azure Load Balancer today. But if you do UDR in the Azure Load Balancer, it's only restricted.
If you do, you do. Sorry, I
So
still
if you do UDR in the Azure Load Balancer,
Yes.
it's extremely restricted. It doesn't work today.
correct. It's almost if it works a certain way in Azure load with UDR, it'll work the same way here. So the same limitations apply though. So
Cool.
that's probably the short answer.
Okay.
Right. Another question. It will do what across hosts? We configure from the controller into VFP to do the mirroring, and it will go from one host to another, yes, because we will encapsulate the packet with VXLAN in that way. And so we don't have to forward it. We don't have to rely on the inner packet for the switch to forward it. We wrap it with its real destination around it, and then, or with the mirrored destination, so it'll go there, and then we unwrap it right as it gets to the appliance that's doing the mirroring. Correct. They don't have to coexist on the same machine. They can migrate independently. You can also do many different DCs to a single ATA gateway. Other questions? Well, get out of the way here. Anyone else?